The notes? Yeah, okay. So we're looking at our assignment. You're going to have your notes out in front of you. In this unit, it's going to be very important that you start with a cheat sheet because this unit has even more information than last unit. Even more, okay? So this unit on the quiz and the test, you'll be able to use a cheat sheet the entire time, okay? Because there's lots of things. If you noticed, our first set of notes were like 3 pages front and back. That's like 3 times as much as normal. Okay. All right. So if I look at this, when it says intercepted arc, what does that mean? Intercepted arc. It's in your notes from last night.
Doesn't mean no one was delayed.
What is an intercepted arc? Look at your notes.
I just thought that was so bad.
Intercepted arc. I'm not asking for the answer. I'm just asking what this means.
Is it talking about how the angles are?
No. That's a conjecture about intercepted arcs. But what is an intercepted arc? Hold on, Kaylee. Kaylee, come back. Kaylee, come back. Kaylee, come back. Yeah. Tell me the definition. What is an intercepted arc? No, what is an intercepted arc? All right. We have located the intercepted arc is on the notes multiple times, but we need to know what it is. So what is an intercepted arc? Look at your notes. At the very beginning, that's where I defined everything. What's an intercepted arc? You should have drawn it on your notes. It says intercepted arc for the angle HTC. It's the arc that goes with that angle. So if I were to draw angle HTC, I'd start from H, go to T, go to C. So HTC is right there. The intercepted arc is the arc of the circle that connects to the outer edges of that angle. Intercepted arc. Okay, so what is the name of the intercepted arc for HTC? You got 2 different ways you can write it. How do we label the arc? We got 2 letters. How should we label the arc? What letters do we have? C and H. So you could call this arc CH, or you could call it arc HC. Both of those are fine. This is called a minor arc because it's less than half the circle. So minor arcs are less than half the circle, and they only get 2 letters to name them. Okay, so this is an intercepted arc. It's called a minor arc. For question 2, it says HTC is 52 degrees. So if this is 52 degrees, now is where we go and look at our circle conjectures. If an inscribed angle is 52 degrees, then how much is the arc? It's double. So 52 times 2, 104. Okay, so the measure of arc CH is 104. I know that this angle is inscribed because inscribed means inside the circle, and inscribed angles have a vertex that's on the edge of the circle. So it's inscribed, it's on the edge of the circle. 52 degrees, when I follow it out, it makes an arc that's 104 degrees. Okay. Next says find the measure of angle CEH. I'm going to switch colors. I'm going to start with C. I'm going to go C to E to H. And I don't have much to give me that angle. So I'm going to go ahead and trace the arc that goes with that angle. And what do you guys notice about the arc that goes with that angle? It's the same arc as the other one. So if the arc is 104, then what's the inscribed angle? 52. So if two different angles have the same arc, then that means that those angle measurements must be the same. Okay? All right, so the measure of angle CEH is 52 degrees. Okay. Next, they're asking for the measure of arc CEH. Whenever you see an arc with 3 letters like that, that means it's a major arc, which means it's more than half the circle. Okay, so I'm going to switch colors again. CEH. So I'm starting with C, then I'm going to E. My green marker's off. Starting with C, I'm going to E, and then I'm going to H. And what do you guys notice about CEH? Yeah, it's like the other part of the circle. So if the first part of the circle is 104 degrees, how do we figure out what the measure of the arc is for the rest of the circle? Subtract it from 360. So an entire circle has 360 degrees. So if we do 360 degrees and we subtract off 104, what do we get? 256. So that means the measure of arc CEH is 256 degrees. All right, I want you to take a moment and see if you can figure out the name of the intercepted arc for THC. So go ahead and draw angle THC and see if you can label the arc for THC. So you are drawing THC. THC. I should see everyone drawing that arc. All right, anyone have an answer they want to give us? The name of the arc for THC? THC is right here. That's THC. So what would the name of the arc be? CT. So THC is right here. So if we follow the angle out, it connects right here, and that would be the arc. So the arc is going to be CT. Okay, find the measure of ECH. Go ahead and see if you can find the measure of ECH. So we're going to draw ECH. And see if we can figure out that angle. Mm-hmm. It's a very artistic lesson. So how much of the circle is that arc? Can you tell? I used yellow. I used yellow for this one. So from E to C to H, there's the angle. I connected it to the arc. Can you guys tell how much of the graph is the arc, or how much of the circle is the arc? It's exactly half. I know that because in the beginning of the problem, they told me that HE is a diameter. and HE is right here. So that goes all the way across the circle. So that means this is half of the circle. How many degrees is half of a circle? 180. So that means this arc is 180 degrees, which means that this angle is how much? The arc is 180 degrees, so how much is the angle? 90. So if your arc is half of the circle, then your angle is a right angle. It's 90 degrees. Okay? All right, for the next one, they ask us to name two inscribed angles. What do they mean when they say inscribed? You have your notes then? What do they mean when they say inscribed angles? You can look back at your notes.
When it goes like from one end.
So the vertex of the angle, the vertex is the pointy part, right? The vertex of the angle has to be on the edge of the circle. So we dealt with one first, right? The very first problem had an inscribed angle. That was HTC. That's one of them. What's another inscribed angle? Angle HEC would be another one. What's another inscribed angle? CT, we already did that one. CTH and HTC are the same. We could do CTU. You guys see that? That's still on the edge of the circle. Angle CTU. All right, I just wrote 3. Now you have to find 2 more. So go ahead and write 2 more. And then when you're done with those 2, you're going to try 6, 7, and 8. 6, 7, and 8. On the same page, if I am showing my work for number 6, I'm going to start off by saying here's the angle, and the angle connects to this arc, right? So we said if the arc is 96, then the angle is 48. And the angle is 48, but the angle is also 2x plus 1. So if the angle is 48 and it's also 2x plus 1, then we should just write 48 equals 2x plus 1, and we have to solve it. All right. When you do solve it, you're going to get a decimal, and that's okay. All right. Let's look at number 7. So I've got one angle right here, and it goes with this arc. And then there's another angle they showed me that's right here. We can see that angle, so I'm going to trace it out. And it goes with this arc. So we've got 2 different angles, and they have the exact same arc. So the 2 different angles have to be the same measurement. If 2 different angles have the exact same arc, then those 2 different angles must have the same measurement. Okay? So if the first angle is x and the second angle is 2x minus 3, then I'm just going to write x equals 2x minus 3. Okay. How should I get started on number 8? There's one angle that's not got any measurement to it. That could be a good place to start. P. Okay, so I'm going to start with P. There's angle P right there. I'm just going to follow it out. And this right here, how big is that arc? It's 180 degrees. How do we know it's 180 degrees? Yeah, from K to R is a diameter. So that cuts the circle in half. It goes across the middle. So that means this arc is 180 degrees, which means what for this angle over here? It's 90 degrees. Okay. Don't say it out loud. I just want you to think about it. Our goal is to solve for x. So don't say it out loud. Just think about it. Is there a way that you could solve for x? Think for a moment. Anyone have any ideas? Somebody other than Kaylee. Anyone have any ideas?
What's your idea? What's your idea? That you're right. Try to cancel out the straight and to get it by itself.
Oh, to get the x by itself? We're going to get the x by itself eventually. So I can see I've got 3 measurements. Say it again? Okay. Why would we add the 2 measurements together? To get what? What did you say to get? Yeah, why would you get 90? You're not wrong, but tell me why. You're not wrong, just tell me why. Yeah, so we know this right here is a triangle, right? How many degrees are in a triangle? 180. So Henry was saying if this one angle equals 90, then the other 2 angles have to also equal 90 because they have to add to 180. Yeah, that's good. All right, so I'm going to say 1/2 x, so there's one angle, plus 1/3 x plus 5, that's the second angle, plus 90, that's the third angle, equals 180 degrees in a triangle always. So we're just adding up the angles equaling 180.
Could you also know that 1/2 x plus 1/3 x plus 5 equals 90?
Yes.
Mr.
Yeah.
So why didn't you transfer the parentheses? Because there were parentheses up there.
You can do parentheses
Like I get it with 2.
to say it's one angle plus a second angle plus a third angle. But since there's no number in front of the parentheses that needs to distribute, you don't need, they technically don't make a difference, mathematically speaking. Yes.
I'm probably getting ahead, but when we set the 2 fractions equal to one another, like
We have to add them together, but not by setting them equal to each other.
I mean, like common denominator.
Yes, we do need a common denominator. Yes. All right. So I want you guys to work on those for a little bit. When we're done with these, we're going to go back to our notes. Okay? So spend a few minutes working on those, making sure we can handle them. Let me know if you need help.